Hello students, here is a presentation on the last topic of 5th module from the subject Principles of Information Security. And the objective of today's class is to outline Bluetooth security issues. Before discussing Bluetooth security, you should understand what a mobile malware is. Malware basically stands for malicious software, and when it's a mobile malware, it is that particular malware which is written to attack mobile devices. It could be any mobile device such as smartphone, tablet, smartwatch, whatever it may be. And these type of malware always rely on the exploits of the particular mobile operating system and mobile phone technology. So it is a very important matter that our mobile operating systems and mobile phone technology should be safe and secure from all these kind of malware attacks. The next point is to discuss on the vector of mobile worm propagation. That is to discuss on how these mobile worms propagate. First method is through app downloads and updates. Second method through Bluetooth technology, and the third method is social engineering. It is when we download various apps or when we update the already installed apps, there is a chance for this mobile malware to get into the connected devices. And the second method is through Bluetooth or any other wireless technology. When different devices gets connected together, there is a chance for the malware in those connected devices to get into our devices. And the third point is social engineering. Social engineering basically stands for the broad range of malicious activities done through human interactions. That is, it uses the psychological manipulation to trick users into making security mistakes or giving away sensitive or confidential information. Next is a small introduction regarding Bluetooth technology. It is a wireless technology standard for exchanging data between various consumer electronics devices. It could be fixed devices or mobile devices. The exchange of data is between short distances using short wavelength. And one important advantage of Bluetooth design is its small size, low power consumption, and low cost. Bluetooth uses a radio range of 2.45 GHz, and as I already mentioned, it covers only short distance. The range is usually less than 10 meter. And several Bluetooth devices can form an ad hoc network. Hope you know what an ad hoc network is. An ad hoc network, basically when we say about a wireless ad hoc network, it is a decentralized type of network which does not rely on a pre-existing infrastructure. That is, it does not require any router or a wireless base station to create the connectivity. When it is an ad hoc network formed from various Bluetooth devices, it is called as a piconet. And in a piconet, one device acts as a master and the other devices act as slaves. Bluetooth was invented by Dr. Jap Hudson while he was working in the company Ericsson Mobile Communication. And this technology was named after the 10th century Danish king Harald Bluetooth, based on the analogy that Bluetooth technology would unite devices. And it is managed by the Bluetooth Special Interest Group known as SIG. And coming into detail about Bluetooth security. Bluetooth security, as any other security method or security measure, it should guarantee the important goals of securities, that is authentication, confidentiality, and authorization. Authentication verifies the identification of devices that are communicating in the channel. And confidentiality is protecting data from unauthorized access, that is, allow data to be accessed by authorized users only. And authorization stands for allowing only authorized users to have control over the resources. And to explain in detail about the various security modes of Bluetooth, there are three security modes. The first is security mode 1, which is basically a no secure mode. In this mode, there won't be any authentication or encryption. That is, the Bluetooth devices can be easily connected to other devices without any security measure. The second security mode is service level security mode. In this security mode, the access control is being handled by the centralized security manager. It includes authentication, confidentiality, and authorization. And the third mode is link level security mode. It is a built-in security mechanism that offers authentication and encryption based on a secret key shared by the pair of devices. It is security mode which is being implemented in the Bluetooth devices that is being used nowadays. Now we shall discuss on establishing connection between various Bluetooth devices. This is a procedure we usually do before initiating connection with other Bluetooth devices. First, we keep our device in a discoverable mode and then search for other connected devices. To explain in detail, to discover other Bluetooth enabled devices in the neighborhood, the device initiates an inquiry procedure by broadcasting an inquiry request, and all devices in range and in discoverable mode respond by sending their Bluetooth device address, that is BD address, that is called as Bluetooth device address. This Bluetooth device address is a 48-bit MAC address. In this, first 24 bits identify the device manufacturer and the last 24 bits specify particular instance of that model. To summarize, Bluetooth is a connection-oriented protocol, and for a device A to set up a connection with a device B, A should know the Bluetooth device address of B. And obtaining Bluetooth device address is through the discovery procedure. That is, the device should be in discoverable mode. Even in non-discoverable mode, that is, if the device is not in a discoverable mode also, there are possibilities for brute force techniques to extract Bluetooth device address of that particular device. So we can say there is a issue, that is, this is a security risk in this kind of connection. Let's continue on the discovery and user authentication procedure. Suppose A and B are the two Bluetooth devices in communication. A could exchange file with B only if A knows the device address of B, that is Bluetooth device address of B. Knowing Bluetooth device address of B, A could exchange files using Object Exchange Protocol. For B to accept the file from A, user authentication is required. And for this, B select a PIN number which varies between 4 and 16 characters. But this level of security provided by user authentication or user authorization, it is inadequate. Here are the security risks of the previous method. That is, first one is, by keeping a phone in a discoverable mode, a user reveals its Bluetooth device address to the attacker. And the second risk is, by disabling authorization or by careless acceptance of files, a smartphone is always vulnerable or open to malware. As there are some risks in the security model mentioned previously, a more secure model, which is called as link level security model, is mentioned here. And in this model, it provides link level authentication and encryption. And for this, the communicating devices on the both sides compute a common secret key which is called as link key. And the computation of this common key or the link key, it is done by the procedure which is called as pairing. So through this pairing procedure, it calculates the common secret key. You might have experienced this pairing procedure when you have tried for connecting Bluetooth with other device, but you didn't know what are the different functionalities which has taken place in this pairing operation. That functionalities we'll study in detail in the next sessions of this class. And pairing is always preceded by the discovery and inquiry procedure that we have already seen. And by doing all these procedures, A establishes a connection with B, and this connection is considered as a secure connection. Next, you can see the various steps for generating link key, which provides link level Bluetooth security. The first step is the generation of the unit key. Next, the second step is the generation of initialization key. And the third step is the step which computes the link key or a combination key. And as the fourth step, you can see how authentication is done using the link key. And then the generation of encryption key, generation of key stream, and finally how a data can be encrypted using this key stream. Now we will see various steps in detail. And the first step is the generation of unit key. Assume that A and B are the two communicating Bluetooth devices. Unit key is a semi-permanent key. That is, it is a semi-permanent key which is generated when a Bluetooth device is operated for the first time. And here in this case, unit key of A is generated by taking the inputs as the Bluetooth device address of A and a random number which is generated by A. Next is the generation of initialization key or K-init, and the computation of K-init is considered as the first step in deriving the common key or the link key between the two communicating devices A and B. And for this, before the pairing procedure, the A and B should agree on a temporary pin. We have already mentioned that the computation of link key is done by a procedure which is called as a pairing procedure. And then the initialization key or the K-init is computed from the temporary pin, the Bluetooth device address of B, and a random number generated by A. And the function which is used for computing this K-init is called as E22 function. And it is based on the block cipher method called as Suffer Plus. Now you can see the diagrammatic representation for the generation of the initialization key. And you can see the two Bluetooth devices, device A and device B here. So as we have explained earlier, it is the initialization key K-init is computed using the function E22, which is based on a block cipher method called as Suffer Plus. So we'll see what are the inputs to this computational function. So initially A generates a random number which is a 128-bit representation, and this random number goes as one of the inputs to the computation of K-init. You can see here A after computing the random number, it is fed to this block. The next input is the Bluetooth device address of B. It is a 48-bit representation. And then the third input is the common temporary pin which has been agreed between A and B. So taking these three inputs on A side, the K-init is computed. And then we will see how K-init is computed on B side. A, after generating the random number, it transmits this random number to B. And on B side, the same K-init is generated using the same function. And then the inputs to this function on B's part is the Bluetooth device address of B, the random number which it has received from A, and then the common temporary pin. So here also K-init is computed with the same inputs and with the same function. Next is the most important computation, that is the computation of the link key. And to compute the link key, both communicating parties, that is A and B, these two parties generate a random number. And this random number is called as the link key random number of A and the link key random number of B. That is the first step. And after generating this random number, A and B, both parties, performs an XOR operation. So that is, it is performing an XOR operation, and the inputs to this XOR operation are the random number which is being generated and then the K in it, that is the initialization key, which is computed already. That is, it does that A and B, both the communicating parties, will perform an XOR operation of its random number and K in it. And after computing this new value, that is after performing the XOR operation, each participant transmit this value across. That is, A will send the resultant of the XOR operation to B, and B will send the resultant of its XOR operation to A. And then each side recovers other party's random number by performing another XOR operation to the received value with K in it. That is, in the first XOR operation, it has the random number plus K in it. This value, after generating this value, it is being transmitted to the other party. The other party, on receiving this value, it will do a second XOR operation to this value. That is, random number XOR K in it, XOR K in it. So, it is able to retrieve the random number back. That is, it is able to retrieve the random number of the other party. And the next operation is the most important operation. That is a identical operation which is performed on both sides A and B. So you can see this operation is performed to obtain the link key or the common secret key, which is generated identically on both sides of A and B. And this key is called by the name key AB or KAB. It is computed using the identical algorithm E21 on both sides of the communicating parties, that is A and B. It is also based on the cipher plus. It is a block cipher method. So after computing the link key, each device store the pair Bluetooth device address of the other device and the newly computed link key in its database for further and future use. So here you can see the pictorial representation of the computation of the link key. You can see the two communicating devices, device A here and device B here. So as if in the first step, we have already explained A and B, both sides, they will generate their own random number for the computation of the link key. That is link key random number of A and link key random number of B. That is the first step. And in the second step, we have seen an XOR operation with the random number and K in it. So this is the operation. Random number of A is XORed with the K in it. And then the resultant value of this XOR operation is being transmitted to B's end. So this is the value, that is this is the resultant of the XOR operation, LK random number of A XOR K in it. After generating this value, A will send this value to B. And on B's side, the operation is, it will do a second XOR operation to this value which is received from A. So after doing the second XOR operation, here you can see this value is XORed with K in it again, and this is the result. So random number of A XOR K in it is again XORed with K in it. Then it will return the random number of A back here at B's end. So here random number of A is returned. The same procedure is done on A's part also. That is B, the first step is generating the random number and the second step is the XOR operation of the random number of B and the K in it. So here you can see the initialization value, that is K in it, which is computed. So K in it XOR random number of B. This is the operation. And here the resultant value is obtained as K init XOR result. init XOR random number of B. This is the resultant value. Random number of B is XORed with K init. And as we have explained already, this value is being transmitted to A. And so the random number of B XOR K init, this is the operation performed and this value is transmitted to A, and when this value reaches A's side, it again the second XOR operation is done with K init that you can see here. This value LK random number of B XOR K init, this value reaches here. This is A's side. It is again XORed with A, and after doing this XOR operation, that is L random number of B XOR K init XOR K init again, it will retrieve the random number of B at A's side. So these are the first three steps. Then the next step is the computation of the link key by doing identical operation. The same key is being produced on A's side and B's side. That you can see here in this operation, and we'll check what are the inputs to this block. So first you can see here at this box, the inputs are random number of A and Bluetooth device address of A. And in the second block, it is random number of B and Bluetooth device address of B. So this random number is generated by B and it is obtained and it is recomputed or retrieved at A's side by doing an XOR operation on the resultant forwarded by B. So this is the calculation of the link key on A's side. Now we will check the calculation of the link key on B's side. So for that we'll see the inputs to these blocks. So these blocks or this algorithm explains the calculation of the link key. So in the first block, the input to this block is the random number of A and Bluetooth device address of A. This random number is retrieved again on B's side by doing the XOR operation with the value received from A's part. The value was the XOR operation of K init and random number of A. It was again fed into another XOR operation with K init again, and thereby it retrieved the value of the random number generated by A. So this is the input, random number of A and Bluetooth device address of A. And in the second box, the operation is the Bluetooth device address of B and the random number. Here you can see Bluetooth device address of B, and then the second input is a random number generated by B. So after examining these two blocks, we are able to confirm that both the sides identical operation is performed, and the inputs to this identical operation are Bluetooth device address of A, random number of A, and then Bluetooth device address of B and random number of B. So this is given as the inputs to this block, and then again the final computation or the final operation in the computation of the link key is an XOR operation on the resultant of these two blocks. So for the first block, random number of A and address of A. In the second block, random number of B and address of B. This again goes to another XOR operation to get the link key. The same operation we can see on A's side also. So this is a very important thing in the Bluetooth security, how the link key is computed on both sides. That is how the common link key is computed on both communicating parties, that is Bluetooth device. Next, we will see the different uses of link key. Link key could be used for both authentication and encryption. And as already mentioned, link key, it is a common secret key. It is computed on both sides, that is on the device A and the device B. So in order to authenticate with B, initially A will generate a random number, and this random number which is generated by A is sent as a challenge to B. And B, on receiving this challenge from A, B will compute a response, and this response is sent back to A. And the computation of the response is done by using the link key KAB, and the other inputs are a random number of A and the Bluetooth device address of B. So after computing the response value using the link key, B will send this value back to A. And when A receives the response from B, A will again do the same function. That is, A has link key, and link key is the key which is generated, or which is a secret key which is generated among A and B only. So A will compute the response value again using the same link key, the random number of A, and the Bluetooth device address of B. Bluetooth device address of B is already known to A. And since link key is the key which is shared only between A and B, after computing the value, A will verify whether the response from B is equal to the computed value. And if both the values are the same, then authentication is success there. If it is not correct, instead of B, it will come to the conclusion that instead of B, some other attacker or some other intruder who is not authorized has sent the response to A, because the link key is known only to A and B. Here is the pictorial representation of the authentication procedure. The authentication procedure. A and B are the two communicating Bluetooth devices. As a first step, A will generate a random number. This random number is forwarded to B as a challenge from A. The random number is forwarded to B as a challenge from A to B. And the challenge reaches B's part. B will send a response back to A as a response to this challenge. And here you can see the algorithm or the function through which the response is computed. So the response is computed using the link key KAB, which is already computed on A's and B's side, and then the other input to the response calculation is the challenge received from A and the Bluetooth device address of B. So after computing this value, this is transmitted to A as the response to this challenge, and this function is used for verifying the authentication. Finally, we will discuss the security issues connected with link level security mode. The first kind of attack is hacking the link key, and the second is social engineering attack. Hacking the link key in detail, we can explain like it is possible to launch a dictionary attack by sniffing the different messages involved in pairing and authentication, and this enables an eavesdropper to obtain the link key, making it possible for the attacker to impersonate B to A under the assumption that link key is known only to A and B. And the second form of attack, it enables an attacker to pair his device with a careless user. That is, when a user connects his Bluetooth device with another device without checking for necessary authentication or authorization methods. So the paired devices are given trusted status, and then these trusted devices can exchange files without further user authentication. And this opened the door to receiving different malware. Now we will conclude this presentation by summarizing the various topics that we have discussed in this presentation already. We started with the mobile malware, that is, we have seen what a mobile malware is, and we have discussed the various methods for worm propagation. Among the various methods, we have seen Bluetooth technology is an important method for worm propagation. Then we have discussed the details of Bluetooth and also the different security modes of Bluetooth. The main security modes of Bluetooth are security mode 1, security mode 2, and then security mode 3. In that we have seen the way how Bluetooth devices could be connected with each other using link level security. And finally, we have also seen the various security issues or attacks on Bluetooth devices. Thank you. Here is the references for this presentation. And that's all for the time being. Please contact me personally for doubts if any. Thank you all.